Shanghai is the busiest and most cosmopolitan city in China. At 7:30 a.m., Chen Shuguang, chief technician of the nuclear medicine department of Zhongshan Hospital, affiliated to Fudan University, arrives at work early to attend an important medical examination. Instead of patients, a piece of state-of-the-art human molecular imaging equipment awaits him. He carefully places an acrylic phantom in the designated place. This phantom is filled with a radioactive solution that emits gamma rays, enabling a performance assessment of new equipment. It will then conduct a full body scan at 2 meters and in just 30 seconds, the longest scanning range and shortest scanning time globally, while significantly reducing the radiopharmaceutical dose to only 1/40th of what is required by traditional equipment. This is groundbreaking technology known as the uExplorer, and it is the world's first 2-meter total body PET-CT scan. Chen Shuguang is checking the uExplorer, while Hu Pengcheng, the physician in charge, is talking to the patient. The patient suspects he has a tumour and is most anxious. He hopes to undergo a precise examination using PET-CT. PET and CT are two distinct medical imaging techniques. PET is capable of detecting subtle pathological changes even before visible structural abnormalities form. However, PET struggles to accurately localize lesions or tumors due to its inherent imaging resolution limitations. CT, on the other hand, excels in providing a clear visualization of the precise location of tumors and infiltration into surrounding tissue. But CT struggles to detect a tumor if it is too small.
如果我们拿一棵这个树来做比方的话，做 CT 扫查呢，我们就可以看到整个树干它的情况怎么样，还有它大的树枝的情况怎么样。PET 扫查呢，我们就可以看到这个树叶它是不是还是很健康，它是黄的呢，还是绿的呢，或者它已经枯萎了。
PET-CT offsets these weaknesses, offering clear and detailed images. It can detect subtle functional changes and provide early warnings, even before any structural variations of the lesion occur. In the nuclear medicine department's preparatory injection room, a nurse administers a radioactive solution to the patient. Unlike administering other medications, the nurse operates through 2 small windows in a wall. The solution is enclosed in a protective tungsten alloy sheath. It is a radiopharmaceutical known as a radiotracer. The human body relies on essential nutrients like glucose and protein for its sustenance. The radiotracer is a unique agent that incorporates radioactive elements to label these nutrients. Once the radiotracer is injected, circulating through the bloodstream, it can reach every part of the body, concentrating in significant quantities near the tumour cells. By visualising the concentration of the radiotracer, the image provides a scientific and visual reference for clinical intervention. However, traditional PET-CT scans have a limitation that needs addressing.
传统的 PET-CT 呢，轴向视野只有15到30公分，所以它扫描的时候呢是分传位来扫描的哈，比如先扫头，再扫肺部，再扫腹部哈，一传一传的下来哈，扫描速度就受影响哈。
The traditional CT approach takes 20 to 30 minutes to scan. This may not seem long, but the human body must be injected with a higher dose of radiotracer, which is obviously not ideal. After receiving the radio tracer injection, the patient is slowly sent into the uExplorer's spacious gantry. With its extended length of 2 meters, the uExplorer accommodates the entire body for a comprehensive scan that takes only 30 seconds. As a result, the amount of radio tracer used can be greatly reduced to just 1/40th of the traditional dose. This means that pregnant women and children can be safely examined. The uExplorer begins the scanning process. The patient may become nervous in the deep, spacious gantry. Fortunately, he gradually relaxes with the help of a circular band of comforting light, a human-centric design element. As the world's first PET CT scanner capable of performing a full body scan in a single session, the uExplorer boasts a crucial component, a 1.94 meter long detector. This 360-degree ring-shaped detector is composed of multiple modules, each housing numerous groups of densely packed crystals. These crystals are sensitive to radiation, which is key to creating images of the human body.
放射器相当于这个 PET CT 的眼睛，把看不见的从人体里面发出来的射线呢，精确地捕捉到，接收到这个射线以后，它会发一种微弱的光，然后这种光通过一个光电转换的器件，那么去把它变成一个电的信号。
This is the mysterious crystal production factory. These rows of futuristic cabinets, resembling cloning chambers, are actually crystal growth furnaces. Specially formulated raw materials are melted into a liquid state at temperatures exceeding 2000 degrees Celsius. A small crystal seed is placed on the liquid surface. As the seed is borne upward, the liquid material adhering to it solidifies and crystallizes due to a rapid drop in temperature. The seed continues to rotate and rise, allowing more crystals to form, ultimately creating a substantial crystal cylinder. Then the engineer uses original BI cutting technology. The machine slowly cuts through the crystal using hair's-width diamond wires, creating an array of millimeter-thick crystals. As a result, these crystals exhibit exceptional reflectivity and impeccable quality.
50多万根晶体相当于是有50多万双眼睛，不停地接收这个人体发出来的这个射线，并对每一个射线做记录。用一双眼睛去看的话，只是从一个角度来获取了一幅图像。但是我们50多万根晶体围绕着人的身体，就可以多角度、高灵敏度捕捉到全方位的射线，出来的这个图像的清晰度和对比度就要比别人高很多。
There are 556,000 transparent crystals encircling the inner wall of the uExplorer's gantry, arranged in more than 600 loops. Each loop consists of close to 1,000 crystals, creating 24 detection modules. The precise and meticulous assembly of all the modules is essential to ensure the perfect detection of signals by the nearly 100 billion detection lines.
那原来可能我们的一个病灶扫描需要1公分以上才能看到，那么它在3毫米就能发现了，更短的时间、更少的辐射能够得到精准的诊断，这是对患者来说有非常好的一个应用。
The total length of the uExplorer's detector is 8 times that of a traditional PET detector. Does it yield an 8-fold increase in detection efficiency? Due to the tight connection of the 8 detector loops and the overlapping detection range between adjacent loops, the actual detection sensitivity of the uExplorer surpasses that, reaching an impressive 40-fold efficiency rate compared to traditional PET. Now, under the gaze of 560,000 crystal eyes, the traces of radio tracers are clearly visible in the patient's veins. They diffuse and accumulate in different regions of the body, unveiling the intricate contours of various organs.
随着时间推移，我们还可以看到这个病人肝脏里面有一个明显的肝脏的病灶逐步的显现。
By accumulating high-definition images meticulously, measured at different time intervals, the uExplorer allows the clinicians to diagnose diseases with remarkable precision and devise scientifically tailored treatment strategies. Blood tests are very common in medical facilities, used to check blood sugar levels, presence of inflammation, or early indications of tumours. However, patients dislike the large amount of blood drawn and the long testing times. Today, an advanced piece of cutting-edge blood testing equipment has been released. The CAL 8000 is China's first original blood analysis line. Now, processing of the initial batch of blood samples is being prepared. The CAL 8000 is not physically large, but it has over 60,000 intricate components. It operates as a miniature intelligent blood testing factory, which can efficiently and accurately analyse the quantity, morphology, and protein content of blood cells in the samples. The CAL 8000 can detect even the smallest anomaly of mutated cells in the blood. Test tubes containing the blood samples have reached the entrance of the CAL 8000. The system comprises fully automated stations. The first station is dedicated to completing the blood count. Its robotic mixing arm repetitively reverses the sample to prevent stratification of the blood and maintain test accuracy. This is the blood separation valve, which is responsible for dividing the blood sample into 5 reaction pools, where it undergoes chemical reactions with specific reagents. As these different types of blood cells emerge from the 5 pools, they are stained and exposed to a laser, resulting in distinct displays of fluorescence profiles. When these cells pass through the detection channel one by one, the inspection station accurately counts and analyses their individual morphology. However, as the blood count and routine examination are near completion, an alarm is suddenly triggered. The system has detected an anomaly, a cluster of blast cells. Blast cells should not be present among normal cell colonies. The presence of an excessive number of blast cells could be indicative of disease. The sample is sent to another specialised station, the slide making and staining recheck station. Upon receiving the alarm from the previous station, the CAL 8000 then initiates the dual line operation mode, sending part of the suspect blood samples to the slide making and staining recheck station. The remainder is sent to the next station, the C-reactive protein, CRP, analysis station. CRP is one of a group of proteins which is considered a marker of infection and inflammation. The CRP analysis station assesses the turbidity level in the reaction mixture to measure the abnormality. At this moment, the increasing turbidity of the reaction mixture indicates a high level of CRP in the blood, which suggests inflammation in the patient's body. The CRP analysis station uses this final turbidity level to determine the concentration of CRP, which then aids in analysing whether the inflammation is due to a bacterial or viral infection. Based on this report, doctors can prescribe the appropriate medication. This is the slide marker, which serves as a vital component of the recheck station. Its primary responsibility is to create blood smears for microscopic observation. A drop of blood is carefully placed onto a transparent slide. Utilising intelligent algorithms and a robotic arm, the slide maker controls a sapphire blade to achieve precise slide preparation. It adjusts the angle and pressure based on viscosity indicators and relevant parameters of the blood sample, which is more accurate than manual slide preparation.
蜕变机的模块将近16000个零件分布在一个这么大的一个空间里面，为了让这16000多个零件有效的运作起来，我们提炼出来的这个设计的这些相互的这个参数指标就达到了10万个以上。
Once the slide is prepared, it undergoes a series of standardized processes to finish its tasks, including staining, washing, and drying. This blood smear, which contains suspicious blast cells, is then forwarded to the slide reader for examination. Equipped with a high-precision motion control system, the CAL slide reader conducts microscopic scanning and imaging of the blood smear at both 10-fold and 100-fold magnification. This enables detailed images of each individual blast cell to be captured. Based on the images obtained from the slide reader, the clinician finally diagnoses the patient with acute lymphoblastic leukemia.
自动的复偏、自动的复查，同时还自动阅片，血液疾病或是异常细胞的漏检率就会大大的减低。
With the CAL 8000's help, this has turned out to be a timely forewarning. The blood samples conclude their journey by returning to the starting point along the outer track. The CAL 8000 can process 1,000 test tubes per hour and conduct examinations on 1,500 blood samples daily, boasting an accuracy rate of over 95%. This remarkable capability allows Chinese laboratory technicians to generate a comprehensive and precise blood test report in just 30 minutes, using only a single tube of blood from each patient. In Beijing, more than 2,000 kilometers from Shenzhen, preparations for an upcoming brain surgery are proceeding in a tense but disciplined manner. The patient has received local anesthesia. Parkinson's disease is a neurodegenerative disorder that mainly affects middle-aged and elderly people. It is associated with the impairment or death of dopamine-producing neurons in the brain. The main symptoms include tremors in the hands and feet, muscle stiffness, and slowed movement, as the patient's body cannot be controlled effectively by the brain.
既往在临床上，我们治疗的手段也非常有限，可以给病人一些左旋多巴的药物啊，一开始效果还是不错的，但是过了几年呢，病人都会出现耐药性，你得加大药物的剂量，但是一加大药物剂量呢，副作用就会出来了，所以在这个时候，病人急需一种新的治疗方法。 来提升他们的生活质量。
The upcoming procedure is known as deep brain stimulation, commonly referred to as the brain pacemaker treatment. At this moment, the neurosurgical robot, Remebot, stands prepared. It will precisely locate the targeted neural cluster, called the subthalamic nucleus, aiding doctors in the precise implantation of the electrodes. Meanwhile, it is equally crucial to determine the entry point on the skull. When the robot reaches the target from outside the skull, a straight line must be followed while avoiding the key functional areas of the brain, According to this principle, the doctors establish the cranial entry point. The Remebot consists of 3 components: an optical camera, a robotic arm, and a computer control system. The optical camera serves as its eyes, employing binocular panoramic vision imaging technology to capture the coordinates of the target patient. The robotic arm carries out the surgical procedures, while the computer control system acts as the brain, analyzing the spatial coordinates obtained by the optical camera and guiding the robotic arm to execute the precise surgical tasks.
把我们的想法，把我们想达到的目的输到机器里边，然后把我们客观的一些指标、客观的一些检查都输到这个机器里边。这个时候，机器就会自动的计算哪儿最捷径，给我们提醒、提示，我们再确立靶点，然后呢，机器再帮我们呢去精准的定位这个靶点。
Brain surgery is extremely difficult. Physiological constraints mean the precision of human hand movements typically has an error margin of about 1.5 millimeters. However, when implanting a 1.3 millimeter wide electrode into the 4 millimeter wide subophthalmic nucleus, the margin of error can only be within 0.5 millimeters. This challenge becomes even more formidable when the surgery is performed under minimally invasive conditions, invisible to the naked eye.
电极一定要插到我们要刺激的核团里面去，你插偏了，那可能效果不好，因为可能会有一些副作用。所以的话，你定位要准。
To achieve such accuracy, the Remebot has to meet strict precision requirements. Since its components have inherent mechanical variability, how can it be ensured that the robot will operate accurately and consistently after hundreds of repetitions? Inside the Remebot's manufacturing facility, engineers are conducting laser calibration tests on the robotic arm. The computer sets a coordinate point and sends the information to the robotic arm, which then seeks out the point according to the given instructions. Simultaneously, a high-precision laser tracks and calculates the trajectory of the robotic arm. If any deviation is detected, an immediate recalibration is performed. Through multiple rounds of calibration tests, the robotic arm achieves the desired accuracy. In the operating room, the Remebot is wrapped in a sterile film. Following the surgical path planned by the doctors, it navigates from the cranial entry point to the target location. Once the robotic arm reaches the designated position, it precisely inserts the probe into the target, achieving accurate spatial positioning and successfully completing its task. Next, the doctors implant 2 delicate and flexible electrodes into the subophthalmic nucleus of a patient with Parkinson's disease, conducting the electrical stimulation.
把这个电极插到异常放电的神经核团上面，干扰它的原来的不正常放电，使它的放电改邪归正。尽管做了这个手术，也不一定就是说脑子里面多巴胺就增加了，但是呢，它这个放电动力学改变为正常了。同样，我们可以消除帕金森病症。
The electrodes have been implanted precisely into the patient's subophthalmic nucleus. Now the long-awaited moment has arrived. The doctors activate the electrodes and adjust the electronic pulse parameter to assess its effectiveness on the patient. The tremors in the patient's arms gradually subside, and the patient regains control over their hands. This positive response to the electrical stimulation provides relief to the doctors and confirms the effectiveness of the treatment. Inside the Tsinghua brain pacemaker manufacturing facility, as a spindle spins rapidly, metal mesh is intricately woven via 48 metallic threads. each with a diameter of just 0.4 millimeters, finer than human hair. The metal mesh will encase the extension wire. It is like clothing pregnant women in a radiation protection suit. After the brain pacemaker is implanted, patients can continue to live normally in electromagnetic environments. The assembled precision components are placed inside a titanium shell. The technician carefully places the shell in a sealed box for the welding process. The welding box is filled with inert gas instead of air. Welding in an inert gas environment not only ensures a tight weld, but also prevents moisture and oxidation. In addition, the Tsinghua brain pacemaker can be recharged wirelessly from outside the body. This overcomes the shortcomings of traditional brain pacemakers, which require operations every 4 to 6 years to replace the battery. The operation is coming to a close, with the implanted brain pacemaker being successfully connected to the extension wire. These 4 hours of surgery, with the implantation of the 37-gram Tsinghua brain pacemaker, will fundamentally change the patient's life. The 2-meter PET-CT uExplorer, the intelligent blood analysis line Cal 8000, the efficient neurosurgical robot Remebot, and the leading Tsinghua brain pacemaker all integrate key cutting-edge technologies and equipment to extend the realms of possibility in medical science. Not only do they help us detect signs of pathological change earlier, they also empower us to improve minimally invasive and non-invasive precision medical procedures for future use.